So I'm starting with a piece of paper, a 15 by 20 piece of paper, and I'm going to cut the corners out and fold up the sides, and I'm going to end up with a box. And so this ends up being this, and my dimension, since I'm cutting off x from this edge and x from this edge, the length of this edge ends up being 20 minus 2x. I start with 15 here, I take off 1x from this side, 1x from this side, so this edge length ends up being 15 minus 2x. And when I fold it up, I get a height of x. So the expression for the volume of this box ends up being looking like this. So I end up volume is equal to length times width times height. So the volume is going to be 20 minus 2x. 15 minus 2x times the height, which I'm going to get is x. So there's an expression for my volume. Now the degree of this we have to figure out. So how many multiplies do I have to get the degree? So the degree would be equal to, well, I have a degree 1, this bracket is degree 1, this bracket is degree 1, so degree 1, I have 3 linear factors being multiplied together, so I'm going to end up with a degree 3. Okay, so this expression for volume is degree 3, which makes sense. Volume is a cube. Volume comes from cubes, so we need a degree 3 to express volume. Area is squares, so I need a degree 2 to express areas. So once I've done this, I want to find out the maximum volume of this box. Well, if I graph this, if I graph the y values as v, I can see where the highest point of the graph is, and that should reflect the highest or the biggest volume of the box. So I'm going to go onto my Desmos and do this and see what this looks like.